Hello my dear students, welcome back to NEET World. So today we will be discussing chemical bonding. So in the last class, if you have observed, we have discussed basics about atom, molecules and their molecular weights, molar mass, and then next we moved to the mole concept and its calculations, interconversions and a few PYQs related to those concepts. Right now all these things were discussed. Then later we have discussed about periodic table and classification of elements, then the periodic properties like atomic radius, ionic size, okay, ionic radius I can say, ionization energy, electron gain, enthalpy, all these things were discussed, electronegativity right now. So in today's class we will be discussing a most important and very basic concepts of chemistry, that is chemical bonding. So we know in nature the molecules, some atoms will combine, exist in the molecular form, and some will independently exist, and some will combine with themselves and exist as a molecular forms. For example, oxygen atom won't exist in atomic form, but that will be in the molecular form, like O2 oxygen molecule we are saying right now. So similarly chlorine, hydrogens, these are also won't exist in their atomic forms, they will combine with themselves and exist in their molecular states. For example, here I am writing hydrogen atom. In the nature it won't be hydrogen atom, it will be exist like H2 gas, hydrogen molecule, okay. Similarly oxygen also won't be in the atomic form, it will be in the molecular form, something like this, O2 form, okay. So it means what we got to know, oxygen won't exist independently, similarly hydrogen also won't exist independently, they will be in their molecular states like this, not in hydrogen atomic states, in their molecular states. If they are not in their molecular states, or even these molecular states may combine to give you H2O like this, H2O molecule. It means independent existence, atomic existence is not there for hydrogen and oxygen, but they will be in their molecular states, something like H2, O2, or when these two combine, we are going to get something like hydrogen and oxygen. When they are combining, we are going to get a water molecule here. So what do we mean by hydrogen? See, we are calling it as hydrogen because hydro means water. Hydro means what? Hydro means water. Water generating compound now. So that's why we are calling H2 as a hydrogen. Okay, in order to produce water we are using hydrogen now. So that's why we are calling it as hydrogen. Okay, I hope the basic understanding the name of this H2 molecule is also clear, right. So from this discussion what we got to know, the elements, some elements may exist stable form in their atomic state only. For example, neon gas, helium gas, how they will be? They will be in the atomic states only. It means what we got to know, yeah, in the nature some species will exist in elemental form, in their stable forms, and some species won't be stable in their elemental form, that's why they combine themselves or with some other things and exist as a molecules like this, okay. So now why this combination or this combining process is taking place? Yeah, so everything in the universe happens to gain the stability. Why it happens? To gain the stability, okay. So in the universe everything, every chemical process is taking place to attain stability. It means hydrogen atom is not stable, but hydrogen molecule is stable. That's why hydrogen won't exist in atomic form, it will be in the molecular form. Similarly oxygen atom is not stable, it is unstable. That's why that atoms combine themselves, then they will be forming a molecule like this. So that's why in the nature we will be having oxygen molecule, but not oxygen atoms, okay. Hope this is also clear. Like this, if you take anything, what happens in the nature, they will be existing in their stable state, okay, right. Now look at this, once read the definition of chemical bond here. The attractive force which holds together the constituent atoms or ions of a chemical species is known as chemical bond. For example, here I am writing hydrogen molecule, okay, hydrogen molecule. Now hydrogen molecule contain two hydrogen atoms now. Now there is something which is holding these two atoms together. That something, whatever the force that is holding them together is called as chemical bond. Particularly here, the chemical bond, we can say it as a covalent bond in this case, because that covalent bond is formed by pairing of these two electrons, by combining of these two electrons like a bond. Okay, so now what type of forces we have? Different types of chemical bonds we have. The first one is ionic bond. Okay, first one is something like ionic bond. Okay, and second one is something like covalent bond. Okay, and third one is hydrogen and coordinate covalent. Like this we have different types of bonds. Okay, I will be explaining about them, but just try to listen. So what I am saying, there is some attractive force which hold two atoms to form a molecule. Okay, so that force is called chemical bond. Okay, how that force is existing there, yeah, we will be discussing about that. Okay, for example here, let us say I have sodium atom. Now sodium will be in its atomic form only in the nature. Ante sodium nature lo ela exist avutundanta, sodium atomic form lo untundi. But when it comes to chlorine, this will be in the molecular state like Cl2. Okay, now if you are breaking this and making an atom out of this, so atomization we can say, now it is something like this, chlorine. Okay, now what happens is this sodium loses electron. Sodium loses electron, exists as Na plus, and one electron is lost. Now that electron is taken by this chlorine, so that it becomes chloride ion. So now what are the charges we are seeing here? One is sodium cation and chloride anion. Right now, so two opposite charges here we are seeing. So now there is some electrostatic force of attraction between the sodium cation and chloride anion that holds them together. That electrostatic force between these oppositely charged ions is called ionic bond here. What is that called? Ionic bond. So now what is the reason for formation of NaCl? See, what is this NaCl? The salt that we are using at our home. While cooking na, table salt we can say, while cooking we will be adding salt na, that is what? Sodium chloride. How this sodium chloride is formed? By combination of sodium ion and chloride ion. Okay, so this molecule is considered to be ionic molecule. Why I am saying ionic? Because there is an electrostatic force of attraction between a cation and an anion. Like that you can understand. Okay, hope up to here it is clear. Right, now this is about ionic bond formation. Now how ionic bond is forming? Once again look at this, atom losing its electron, one atom is losing its electron and becoming a positive charge. This is called cation, I hope you know. Okay, now whatever the lost electron from the sodium is taken by the chlorine atom, therefore it is becoming anion. So what you are seeing, complete transfer of electron is taking place from one atom to another atom. The complete transfer of electron is from sodium atom to chlorine atom is taking place. So this electron transfer is taking place now, that results to form an ionic compound. What type of bond? Ionic bond. Okay, now look at this. See, why chemical bond formation happens? Why? Because the nature loves to exist in stable form. Nature loves stability. That's why in the nature everything happens naturally to gain stability. Okay, అంటే నేచర్లో ఏ ప్రాసెస్ అయినా ఎందుకు జరుగుతుందంట? స్టెబిలిటీని గెయిన్ చేయడానికి జరుగుతుందంట. ఓకే, ఇక్కడ సోడియం క్లోరైడ్ ఇలా ఏ మాలిక్యూల్ అయినా ఎలా ఫామ్ అవుతాయి అంట? బై లూజింగ్ ఆఫ్ ఎలక్ట్రాన్, బై గెయినింగ్ ఆఫ్ ఎలక్ట్రాన్. అంటే ఏం జరుగుతుంది? సో దోస్ హూ ఆర్ లెస్ స్టేబుల్, దే వాంటెడ్ టు బికమ్ ఏ మోర్ స్టేబుల్. So during this process anything may happen. Okay, so here in order to form a sodium chloride compound, what is happening? Sodium atom అనేది electron lose అవుతుంది, chloride అనేది electron gain అవుతుంది. There will be positive and negative charges that holding them together. Right now, so here transfer of electrons are taking place. Now nature allows stability, I am saying now. So now elements try to attain noble gas configuration. Why they are attaining noble gas configuration? The species, the elements in chemistry, the elements with noble gas configuration are stable. Once again, the elements are the species with noble gas configuration are stable. So what do we mean by noble gas configuration? See, in the periodic table if you have observed, so I told you that 18th group now, what are the 18th group elements here? I told you helium, neon, argon, krypton, xenon, radon, like this we have. So all this element, if they also have, if the other elements are also having this many number of electrons, then we can say those species are stable. So simply you count 8 electrons should be there in the valency. Okay, and ఇప్పుడు sodium చూడండి, sodium after losing 1 electron, atomic number is 11, by losing 1 electron it become 10 electrons only, by losing 1 electron it become 10 electrons only. So 10 electrons is nothing but neon gas configuration. Okay, right. Next, chlorine atomic number is 17, whereas argon atomic number is 18. By gaining one more electron, this chlorine 17 electrons become 18, that is nothing but argon electronic configuration. Therefore, by losing or by gaining, what they are attaining, the nearest noble gas configurations they are getting. By that they will become stable compound, they will form stable compounds or molecules. Okay, I hope it is clear. Okay, now see, the elements try to attain noble gas configuration, that is 8 electrons you can see in their valency, like you can say octet configuration in the valency. Okay, now this inert gas configuration, noble gas configuration can be obtained or attained by following process. First process is transfer of electrons. See here, one electron is completely transferred now, so that transfer of electron may gives you the stability for some compounds, for some elements. Okay, if the compound is formed by transfer of electrons in the elements, then you can say that compound as ionic compound. Which compound it is? Ionic compound. Now it can also be happen by mutual sharing of electrons. What is the next topic here I am saying? By mutual sharing of electron. So what do we mean by mutual sharing? Just listen here what I am saying. See, mutual sharing is nothing but, let us take fluorine atom. So fluorine atom atomic number is how much? Fluorine atomic number 9 na, you put 9 dots here, I mean 9 na, so 9 means write its electronic configuration like 1s2, 1s2, 2s2, 2p, 2p, 5 we will be writing. See, 4 plus 5, 9 electrons over now. So this is outer shell electronic configuration, this is inner shell, don't consider about this. What is the valency electronic configuration we have? Ns2, Np5. So total 7 electrons are there in the valency. You put 7 dots like this around the fluorine. 1, 2, 3, 4, 5, 6, 7. Okay, so still how many electrons are required to become 8 in the valency? Like see, this N indicates this 2. Okay, that is what valency, outermost shell. అంటే ఎక్కువ highest n value ఏది ఉందో అక్కడ మనకి 8 electrons ఉండాలి. ఇక్కడ ఉన్న 8 electrons, only we have 7 electrons కదా. So one more electron is required. So now what happens in this case is, you take 2 fluorine molecules, fluorine atoms like this. Okay, now what happens? This is also having 7 electrons, this is also having 7 electrons. Now if they mutually share this 1 electron to them, what happens? Now look at this fluorine, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So these electrons, they have made a bond here by mutually sharing. Now look at this, 6 electrons, 6 are non-bonding electrons and 2 are bonding electrons. So you can say these electrons, these electrons belongs to fluorine, these electrons belongs to this fluorine as well as this fluorine. So it means their electrons are mutually shared. So total number of electrons on each fluorine will become 8 now. Once count, 1, 2, 3, 4, 5, 6. Okay, 6, 7, 8. Similarly to this also, 6 plus 2, 8. So both of them are getting 8 valency electrons now. That is nothing but noble gas configuration, inert gas configuration. So like this, some elements will completely transfer the electrons to make a bond, or some elements will mutually share the electrons to make a bonds and become a stable compound. Yeah, when we are mutually sharing, when we are sharing the electrons mutually between the atoms, that bond will be considered as covalent bond. So how a covalent bond will be formed? By mutual sharing of electrons. Okay, remember this line. Okay guys, if you are new to this channel, just click on the subscribe button so that you will get daily classes from our side. And also if you like this concepts, whatever you are following here, if you really liked it, just click on the like button and you can share with your friends. Okay, right, let's move forward. Yeah, let's move forward then. Okay, so now once again, what is the chemical bond? I told you definition of chemical bond, the attractive force which hold the atoms together together in order to form a compound is called chemical bond. Okay, right now what are the types of bonds we have? I told you about ionic bond or electrovalent bond, how it will be formed by complete transfer of electron from one atom to the another. Right now the next covalent bond, how a covalent bond formed? I told you by mutual sharing of electron. Once again here I am saying, I told you that hydrogen won't exist in the atomic form, but it will be in the molecular form like H2. Why it will be in the H2? See, hydrogen atom has only one electron as its atomic number is 1. Similarly, you take one more hydrogen atom here. Okay, so now what happens? See, if they share this electron together like this, they can make a bond. Okay, so now what happens? How many electrons are there with each of this hydrogen? So 2 electrons with each of the hydrogen, I can say. Why? These are mutually shared now, belongs to both of them. So 2 electrons here, 2 electrons here, you can say. Okay, so or you can simply say it as a duplet configuration. What is that called? Duplet configuration. Okay, so like helium gas configuration now. So only in the case of hydrogen you need to consider or compare it with the nearest noble gas, that is helium, because hydrogen 1, helium 2 now, that's why. For hydrogen only you compare with helium. For all other elements, compare with the other noble gases, nearest noble gases. For example, you are considering carbon. So carbon atomic number 6, you compare it with the 10th element, that is neon gas configuration, 10 atomic number 10 now. So for all these elements you need to have in the valency as 8 electrons at least. Okay, how many electrons should be there? 8 electrons. Okay, if they have 8 electrons, you can say it as octet is completely filled. Okay, right. So now look at this carbon electronic configuration. If you write 1s2, 2s2, 2p2, so it means how many electrons are there in the valency? Only 4 electrons are there. Now you put 4 dots like this. After putting, see, I am saying a word called valency. What do we mean by valency? See, here you are writing 1, here 2, 2. So bigger number 2, this is called principal quantum numbers. All these are coefficients are called principal quantum number. So highest principal quantum number is here only now. So it means more n value, more is the energy. So highest energy level is this 2. Okay, so in this valency shell, in this energy level, how many electrons we have? 4. Only that 4 will be taking place in the chemical reaction. You don't take these 2 electrons, these won't participate in reactions. Okay, right. So 4 electrons are there. In order to become stable, how many bonds it can make? Yeah, it still more required 4 electrons, so that 4 plus 4 it becomes 8. Therefore carbon try to pair up with 4 other elements who can donate 1 electron at least. Okay, like this. So for example, carbon, hydrogen are combining, therefore we are going to get a methane like CH4, because 4 electrons from carbon and 1 electron from each of that 4 hydrogen. Therefore total electrons will become 8 for carbon and 2 for each hydrogen. Okay, hope the discussion is clear up to here. Right, so covalent bond is over. Ionic bond is also discussed. Next, coordinate covalent bond. What do we mean by coordinate covalent bond? See here, sometimes we have seen a bond is formed, a covalent bond is formed by mutual sharing 1 electron from each of the atom. But in coordinate covalent bond, what happens, you know, both electrons are given by only one species. In order to make that covalent bond, both electrons are given by one species only. For example, here I am taking ammonia for better understanding, and here BF3 I am taking, or BCl3 you can take. Okay, so now what happens is this boron has one empty orbital. To that empty orbital, this pair of electrons are donated. Okay, see the pair of electrons, see, in order to make a bond, 2 electrons are required, or I can say a pair of electrons are required. All that pair of electrons are given by only one species, means you can say that bond as coordinate covalent bond. What is that bond called now? Coordinate covalent bond, because both electrons are coming from one species only. So this is the indication of coordinate covalent bond. Okay, right. Hope it is also clear. Next, metallic bonds that is exist in metals, we will be seeing them in later. Okay, and this hydrogen bond, van der Waals forces, these are electrostatic forces and dipole-dipole interactions. We will discuss them in the upcoming sessions. I mean, when we start the class of chemical bonding, there we will discuss, but the first 3 things are important as of now. Okay, right. Okay, so I told you one atom donate the electron, other will gain that electron. Okay, overall it will form 2 different opposite ions, okay, that have electrostatic attraction, results to form a ionic bond, I told you right now. So these are the definitions that you required. Okay, so make a list of this definitions. Already we discussed everything about this covalent bond and ionic bond. So how covalent bond is formed? By mutual sharing of electrons, right? Yeah. So when they mutually share, they are going to get duplet configuration in the case of hydrogen and octet configuration in all other cases. Okay, right. So when they are sharing the electrons, for example, 2 carbon atoms are combining. Now how many valence electrons we have seen? 4 valence electrons we have seen now. So here maximum the bonds, number of bonds between carbon can be 3. So like this, 1 sigma bond, and by one more electron pair, one more sigma pi bond, and here one more pi bond. Okay, so 2 pi bonds and 1 sigma bond can be formed between 2 carbon atoms. Okay, now what about this? Yeah, here it can combine with hydrogen like this. So between carbon we can see multiple bonds also like this. Okay, so when they are forming multiple bonds, always consider the first bond as sigma bond and the remaining extra, whatever the extra bonds we have, those are pi bonds. Let us say this is sigma and the remaining 2 are pi bonds. Okay, so when you are writing triple bond between 2 carbon atoms, you should call it as alkynes. What you should call? Alkynes. So about this alkenes, alkynes, alkanes, I will be explaining in the organic chapters when I discuss about that, but I hope up to here it is clear, right? Yeah. Next. Okay, now what are the properties that ionic and covalent compound shows? Okay, so first of all, ionic compounds here, covalent compounds here, the state, generally most of the ionic compounds are solid. You can say anything, for example, salt only you take, rock salt, how it will be? Crystalline solid, right now. So that's why here generally it is solid. Okay, next, covalent compounds found in all states. For example, sugar is an example of covalent solid. Okay, and water is example of covalent liquid. Okay, and there are many gases like oxygen, nitrogen, these are examples of covalent gases. Okay, so covalent compounds may exist in solid form, liquid form, or gaseous state. Okay, all possible states are there, found in all states. Okay, but most of the ionic compounds will be in the solid state. Okay, crystalline forms again. Okay, melting point and boiling points is more for ionic compounds because there is a strong electrostatic force of attraction between oppositely charged ions like a cation and anion. So that makes it to have more boiling point, more melting points. Okay, that's it. Okay, next one. So covalent compounds are generally having lower melting point compared with the ionic compounds. Once again, ionic compounds have high melting and boiling points due to the electrostatic force of attraction between the ions. Okay, next, electrical conductivity. When it comes to electrical conductivity, the solid components are there. Now in solid form they won't conduct, but if you melt it, in the molten state, ionic compounds are very good conductor. Why very good conductor? When you take molten form of it, molten form of sodium chloride, if I say sodium cation, chloride anion will be there, they can mobilize here and there, that will be responsible for ionic, electrical conductivity. Right now, similarly, even if you take pure water, it's a poor conductor, I can say. Okay, poor conductor of electricity, I can say. But if you add small quantity of salt to it, what happens? Now it becomes a very good conductor. Therefore, in their aqueous solutions, ionic compounds in their aqueous solution or in their molten state are very good conductor, but in pure solid form, bad conductors. Okay, so you can say molten form due to movement of free ions, whereas covalent compounds are poor because no charged particle, because there is no charges. We haven't discussed anything about charges in covalent compounds, but we discussed purely about Na plus, Cl minus, like that we are seeing cations, anions, na, those are responsible for electronic, conductivity, but there is no such kind of thing we are going to see in this covalent. So these are considered to be poor, and here it is good conductor. Okay, right. Next thing is, and there are, covalent compounds, there are a few conductors also, but generalized statement is poor conductors. Sir, what is the best example for covalent solid which is a conductor? Means graphite. What is it? Graphite. So in graphite what happens, that graphite contains layers like this. Now graphite means that pencil lead that you are using. Okay, so like this you will be having electronic transition, like layer like structures will be there. So these electrons keep on moving like this. So due to the mobility of pi electrons, here in covalent compounds also sometimes we will see the conductivity. Okay, hope it is clear. Next, now they are asking a question here. How simple it is. See once, the formula of a compound that is ionic compound, particularly ionic compound that is formed by sodium and sulfur. Sodium and sulfur. When these two combines, what is the ionic compound we are going to get? So tell me, how can you write the structure of it, a formula of it? See, I told you one statement when we are discussing periodic table, that all alkali metals like lithium, sodium, potassium, rubidium, when they combine with anything, they will become a unipositive charges, unipositive ions. It means sodium loses one electron, becomes sodium cation. Okay, like this, whenever it is combining with anything, it will be the scenario. Okay, since here losing one electron by the sodium atom, now come to the sulfur here. So sulfur belongs to 16th group now. So 16th group means in order to become a 18th group, 2 more electrons are required. That's why sulfur gains 2 electrons, try to gains 2 electrons and becomes sulfide ion, S-2. So in order to form S-2, how many electrons are required? 2 electrons are required. But one sodium atom giving only 1 electron. So let us take 2 sodium atoms, becomes 2 sodium ions. So 2 electrons. So these 2 electrons are taken by the sulfur and become sulfide ion. So totally it is S-2 and Na plus, how many Na plus? 2 Na plus. When these two combines, we are going to get something like this, Na2S, sodium sulfide. What is this called? Sodium sulfide. So this is the compound formed here. Hope the discussion is clear and the concept is also clear, right? Yeah, guys, if you have any confusion, please let me know. Aishu, hi. Next, let us discuss few more things. Yeah. So there is something called a Lewis dot structure. So what do we mean by Lewis dot structure? See, water molecule you are writing something like this, and methane means you are writing something like this. Okay, like some structures or some molecules we are having now. Now what are the molecules? We know water molecule, methane molecule, okay, and ammonia molecule, all these we know. But who explained all these compounds? Because till now we do not know anything about how the molecules are formed, right now. So in order to explain the formation of molecules, some basic approaches were developed. The first one here and well known one is Lewis dot structure. What it is? Lewis dot structure. In a molecular formation, what he says, dot structure explains it in this way. The molecule formation takes place only by outer shell electrons, that is valency shell electrons. Okay, it means here I am saying carbon atom. Now how many valence electrons are there in the carbon? I told you. I hope you know writing electronic configuration, like 1s2, 2s2, 2p, 2p2. So this is called valency shell electrons. How many are there? 8 are there, 4 are there. No? You take each electron as one dot like this. Okay. Now similarly at the same time we will be doing for other examples also. Okay. Now what about a hydrogen atom? Hydrogen atom contains 1s1 electronic configuration as its atomic number is 1. Okay. Right. Now what I am saying here is, so one electron of hydrogen you take as one dot. Like that each electron on each of the atom as dot. Like that, in order to make the octet configuration, what do we mean by octet configuration? The element should have 8 electrons in its valency. Okay. So how many electrons are there in it? Only 4. So still how many electrons are required? 4 more electrons. No? So that's why carbon atom can combine with 4 other atoms, with other atoms to make 4 bonds. Now for example with hydrogen, how many it can be making? So with one atom, one bond. Like that this side also one bond, this side also one, this side also one. Like that we are going to get 4 bonds around the carbon, right? So this is the story of octet. See why? Because each bond contains 2 electrons. Like that 4 bonds are there, 8 electrons we got. Okay, hope the discussion is clear. Right. Not only this, now go for ammonia, NH3. Okay. Now tell me how many valence electrons with the nitrogen atom, atomic number 7, 1s2, 2s2, 2p, 2p, 3. So total valence electrons are 5. So you put 5 dots around the nitrogen like this. Okay, done. How many hydrogens are there here? 3. So each hydrogen will make one bond like this. Okay, and one more set of lone pairs will remain as it is on the nitrogen. Okay, so now these non-bonding electrons, did they formed in any bond formation? No, no. So these are called non-bonding electrons. What they are? Non-bonding electrons or lone pair electrons. Non-bonding electrons or lone pair. So these are bond formation now. So how many bonds are there? 3. So bond pair electrons are how many? Bond pair electrons. So like 1, 2, 3, 4. So bonded electrons are 6 electrons are there. Okay, like that you can understand. Okay, hope the discussion is clear. Right. So he explained it very clearly by considering octet rule configuration. Okay, if the elements, if the compounds attaining noble gas configuration, octet rule configuration are considered to be stable, he told. What he told is noble gases are stable. What is that? Noble gases are stable. Noble gases means helium. So when hydrogen combine, it will get 2 electrons. That's why hydrogen molecule is stable when you compare with the hydrogen atom. So hydrogen atom won't exist, hydrogen molecule exists because it will have a 2 electron system as like nearest noble gas, that is helium. Okay. Similarly, when it comes to neon, so all the other species this side like carbon, nitrogen, they will make the respective compounds like methane and ammonia like this, because to gain valency electrons as 8, which are nothing but neon gas configuration. Like this he told that the molecules combine with other species to get octet rule configuration. What is that octet rule means? 8 electrons should be there in the molecule formation, after formation of molecule. Okay. So like this he told, but there are some species which are having lesser than the octet electrons, lesser than the 8 electrons are also being existing and they are being stable. The best example for that is BF3. See, boron. How many valence electron? Boron atomic number is 5. So 1s2, 2s2, 2p1. Right now valency means this many electrons. So 3, 2 plus 1, 3 now. So you put 3 dots. Okay, 3 dots is fine. Next I am saying about BF3 molecule, right? So 1 fluorine here, 1 fluorine here, 1 fluorine here. Each fluorine having 7 valency electrons. Like this, you can make a bond like this. Okay, now count number of electrons on the boron. See 1, 2, 3, 4, 5, 6. So 6 electrons are there with the boron. but what we got to know from Lewis explanation, there should be 8 electrons in the molecule, then that molecule is stable. But this fellow, this BF3 molecule are having only 6 electrons in the boron atom in the molecule, central atom, but this is also existing and it is a stable. Okay, therefore the Lewis dot structure got failed here. So what as per him, there should be 8 electrons, octet number of electrons, but there are some elements with lesser than the octet. It means I can say these molecules as incomplete octet. What is it? Incomplete octet, incomplete octet. And there are some molecules like PCl5 which are also stable and existing, okay, with expanded octet. What I am saying? Expanded octet. So these are the limitations, expanded octets. These are the molecules having expanded octet which are also existing like a stable. Okay, therefore he was unable to explain why these molecules are stable, how they are existing if you are taking only octet configuration. Okay, so this is the limitation of octet. The next limitation is like this guy, who is this Lewis, told that just take electron as a dot on one atom and one more dot on another electron on another atom to make a bond like this, but he not explained what is the nature of that bond. It is not explained about nature of the bond and what is the structure of the molecule, whether it can be T-shape, whether it can be tetrahedral, whether it can be octahedral. These structures, orientation of atoms around the central atom is not explained. Therefore, those are also considered to be limitation of Bohr's limitation of Lewis dot structure. Okay, remember this. Okay, next. Right. Everything is over. You can go through these lines that I have explained already. Yeah. So these are the limitations I told now. What is the limitation I told you? Incomplete octet. Some elements with less than 8 electrons are also being stable. Okay, and when it comes to expanded octet, some elements like PF, PCl5, SF6 existing more than 8 electrons, that is what expanded octet, they are also stable. Okay, that is also a limitation. Next, noble gases. See, the fundamental concept here he used is species having inert gas, noble gas configuration are stable, they won't show any reactions. Okay, but you know what happened later? The xenon is a noble gas itself forming some chemical reactions, itself showing some chemical reactions like forming compounds like xenon, difluoride, tetrafluoride, hexafluoride, all these things. Okay, therefore this is also considered to be one of the limitation. Okay, right. Yeah, so now that is about Lewis dot structure explanation. Now go through this question, which are the following violating Lewis dot structure? Yeah, tell me which of the following violating Lewis dot structure. See, the first option itself says your answer, because boron having only 3 valence electron, when they combine with chlorine like this, you can make 1-1 bond. See, chlorine has 7 electrons, that 7th and this 8th, chlorine is happy with octet rule configuration. But what about boron? Boron is having only 3 bonds, no lone pair electrons, empty orbital only it has. So I can say it has only 6 electrons in the valency, right? So 6 electrons means incomplete octet. They are saying violating octet rule. So the first option is your best for the discussion. Okay. Now like that you can go through the remaining 3 options and verify whether they are following octet rule configuration or not. If they are following, no issues. If not, you mention that in the comment box. I will be looking into it and I will simplify that if you have any confusions there. Okay, right. Next, in which are the following compound expanded octet on central atom is present? Yeah, so just to go through this, BF3 octet rule we know. Hydrogen, in case of hydrogen only you just check for duplet configuration. What is a duplet? It means 2 electrons are enough here, like helium. In all other cases 8 electrons, octet. Okay, yeah. So CCl4 carbon, definitely it has octet configuration. You can go through that. So the only remaining option is 3, that is PCl5 is your answer, because it has 10 electrons. Okay, now try to answer me this, which are the following contain both ionic and covalent bond out of the 4 options. Okay, see, when it comes to NaOH, it will be Na plus OH minus. Okay, but within the OH minus, like it will be like this. So between these two it is ionic, between O and H it is covalent. So contains both covalent ionic, first option. Okay, go with the next option also, KCN. So K plus Cn minus. So from these two explanations you need to know that always whenever you see alkali metal ion, alkali metal, you take it as a unipositive ion like this, Na plus here, K plus, like that. Where in between carbon and nitrogen here, so what happens is you put negative charge here, so 3 bonds will be there with nitrogen. So these are covalent bonds. These are what? Covalent. So here it is ionic, this is covalent. Okay, hope this is also clear. Okay, so between Na to SO4, can you try that? Yes, you can try. So the option definitely will be fourth. Why? Because Na plus means 2 Na plus ions. How many sodium atoms are there here? 2 now. So take them as 2 ions. Okay, now sulfate ion should have minus 2 charge. So these are 2 ions. So ionic bond is existing. Between sulfur atom and oxygen atoms? Yes. So these bonds, all these are what? Covalent bonds only. So all of them have covalent as well as ionic bonds. So fourth option will be perfect for our discussion. Hope the discussion is useful, and I hope you followed the complete discussion. So if you have joined at the last beginning, ending of the session, just go back and watch complete session. If you have any confusion, please let me know in the comment box. Okay, now what is your duty? Once again rewatch this and make a conclusion out of it. Okay, then later if you have anything related to chemical bonding, whether it can be class 10th notes or books or intermediate books, just go through that. If no books, just go through the internet, Google or NCERT books, you can go through the online sessions. Okay, and you can once again make some conclusion, solve some questions. Okay, and be prepared for the next session also, so that it will be easy to understand and easy to actively participate in the class, right? So thanks for watching. Stay connected with our NEET World channel. Thank you.